Hi, my name is José Manuel Linares Felipe, and what you're about to watch is the result of the Italian introductory workshop for the KIC's Pioneers into Practice program 2012. The chosen theme was Food and Water in 2050, to which we have tried to apply the smart grid concept. They don't seem to be related at all, but stay with me and you'll see an interesting connection there. Our work is called Full Smart Grid. What is a smart grid? A grid trying to be smarter should fulfill 4 different features, but often just 3 are required. Efficiency, understood as the optimization of the whole grid and each of its components. Quality, i.e., the improvement of its service in every way. And adaptability, which is the capability of response to multiple scenarios. The fourth one we propose is justice. We should measure our dependence on every kind of grid. Is it growing? Is it fair? This aspect is rarely considered in technical literature, but we think it's time to consider it as one of the fundamental conditions for a grid to be smart. So, what makes a grid smart? Anyone can understand a simplified standard grid. Basic strategies to improve this scheme are decentralization in every way, space, time, and type of source. Monitoring at every level, from production to consumption. And self-production, which is usually based on renewable energy technologies. But is this enough for a grid to really become smart? We don't think so. Once again, we propose a fourth strategy as the crucial step for a grid to be considered really smart. In addition to decentralization, monitoring, and self-production, feedback should be also taken into account. In fact, feedback by itself has the power of maximizing all the previous features. To understand feedback, let's have a look at a well-known smart grid, the power grid. Here, the traditional phases of the supply process are easily recognized. This scheme was completed when the renewable energies were adopted, but the grid didn't become smart until this moment, when a new technology added a new phase, bringing energy back in the opposite direction. And the little creature who did the trick was the inverter. An inverter is a device that manages a flow in 2 different directions, allowing the introduction of self-produced energy into the public grid. In this way, the user benefits from a semi-autonomy status, covering demand peaks with the public grid, and selling back its extra production. Is this applicable to other kinds of grids? Even for water and food, it is possible to identify the different phases of the supplying process. And self-production technologies have been available much longer than for other grids, but they still lack the crucial feedback phase. So why not applying this feedback principle to all kinds of grids? The Internet, the smartest grid by excellence, was made possible by a 2-way device. The power grid has available technology and is already getting smart. Heating grids have also the necessary components just waiting to be used in the right way. For gas, the Emilia-Romagna region is a first-class developer of biogas technologies and works for an inverting device seen to be in progress. What about water? Well, devices for extracting, storing, and filtering water are available to the public, but a water inverter is still to be invented. For food, self-production is not a problem, so an inverting process could be tricky, but certainly not impossible to develop. Besides, the right mechanism could be already taking shape, at least on a small scale. Markets selling fresh local produce are a clear example. But why just supplying grids? Cannot a waste system use the same concept? Despite the existence of well-tested self-processing technologies, a sewage inverter hasn't come to anyone's mind. Solid waste is already pre-recycled in every household, and lots of items and materials can be reused through special scrap exchange centers. So, this could be the agenda for our vision on food and water in 2050. The development of two different inverters to convert their respective grids into fully smart grids. Each of them will raise different problems, which could require many experts to be solved. But it will be certainly an interesting and exciting challenge to take. Our final vision is a future where every grid is a full smart grid, or more precisely, where users have the chance to choose for what energy usages and in which percentage or moment they prefer to consume or produce. I hope you have enjoyed this presentation and that it will provide some good food for thought. Thank you for your time.